Hi, my name is Margaret. In this video I'm going to introduce you to inheritance. Inheritance is a form of software reuse. A new class is created by absorbing the class members of an existing class. Existing functionality can be modified and new functionality can be added. So at this point I want to show you an example. Let's say we have a class called dog. Dog has an attribute, that's the breed. It has a constructor to initialize the breed, and it has some operations. It knows how to communicate, that is by barking, and it knows how to move, that is by running. It also has a getter, so we can check what breed the dog is. Notice it has no setter. Once a dog has been created with a given breed, that doesn't change over the lifetime of a dog. And now let's say in my application I have a second class. The second class is sled dog. Once again it has a breed, a constructor that initializes the breed, it communicates by barking, it moves by running, it has a getter, but in addition it also knows how to pull a sled. And when I look at those two classes I can see that they are very similar, they have a lot in common. And I could write two separate classes that share a lot of class members, but a better way to do that is to use inheritance. So here I draw a relation between my two classes, and the relationship is indicated by this arrow here. Notice it's an empty arrowhead with a triangular arrow tip, and it points from my sled dog to my dog, which means my sled dog inherits from my dog. So here we have software reuse. We don't have to redeclare all those common features over and over again. We can absorb them from the parent class, from the class we're inheriting from. And in our particular case, we don't modify any functionality, but we do add functionality. We add an extra operation called pull sled, because my sled dog knows how to pull a sled. Let's have a look at the difference between a has a and an is a relationship. A has a relationship represents an association. An object contains a reference to another object as a field. So here we have some examples. I could say a student has an address. A polygon has a number of points. A college has a number of teachers. Notice one class can have multiple has a relationship. A college can have a number of teachers and an address. So here is once again a UML diagram to show this has a relationship. Notice the different arrowhead here. It is not a triangular arrowhead anymore. It's only an arrowhead with two sides. And it goes from student to address, which indicates the student knows about the address. The student has an address. And here it has a multiplicity. It says 1, which means my student has exactly one address. Is-a relationships are different. Is-a relationships represent inheritance. An object of a subclass can be treated as an object of the superclass because it is a superclass member. So let's look at that. A student is a person. If I need 3 persons, I could use a student to be one of those persons because a student is a person. It can be treated as a member of the superclass person. A polygon is a two-dimensional shape. A college is an educational institution. Once again, lots of is-a relationships. And on the left side we have the subclass. This is the class that derives. This is the class that absorbs class members from the superclass and reuses the code that has already been declared. On the right side, we have the superclass. Superclass is typically more general. In my superclass, I specify those class members that are common to multiple subclasses. So I can say my subclass is a superclass. My superclass tends to be more general, while my subclass tends to be more specific. One superclass can have multiple subclasses. However, each subclass has exactly one direct superclass, and that is called single inheritance. So in Java, it is impossible to inherit from multiple classes. Each class has exactly one direct parent class, or how it is called in Java, superclass. Let's look at this example. Let's say we are in a college context. We have community members. Those could be employees, students, alumni. And there are different kinds of employees, faculty and staff. And there are even different kinds of faculty, administrators and teachers. You can see one class, in our case community member, can have multiple subclasses. However, each of the classes has exactly one direct superclass. Notice the arrows with the empty triangular arrowhead. They indicate inheritance, so I can say my faculty is an employee, my employee is a community member, etc. Now it's your turn. Come up with 3 examples of inheritance. Identify the superclass and its subclasses. Pause the video, and when you're done, press continue. So here are 3 possible examples. I could say my superclass is student, and my subclasses are undergraduate student and graduate students. Both undergraduate and graduate students are students, so we have the is-a relationship, and they share common attributes and operations. For example, all students have a student ID. I could say my superclass is a loan, and my subclasses are car loan, mortgage loan, home improvement loan. And my third example, employee. I could say my superclass is an employee, and my subclasses are full-time employee, part-time employee. Now let's have a closer look at the subclass. Multiple subclasses can inherit from one superclass. Subclasses inherit all the public and protected members. Those are fields, methods, and nested classes from its superclass. Constructors are not members, and they are not inherited by a subclass. However, the constructor of a superclass can be invoked from the subclass. Now, besides inheriting from the superclass, subclasses can also add new features. For example, they can add their own members, fields, methods, and they can modify. They can override or redefine an inherited superclass method with an appropriate implementation. Notice, when you want to change the functionality of a method from your superclass, you can override it, but you cannot override a constructor. You have to write your own constructor for your own class if you need a parameterized constructor. But to prevent code repetition, you can call the superclass constructor to do the initialization of the shared class members. Now let's have a closer look at the superclass. Superclass is the class from which the subclass is derived. If no superclass is specified, the class implicitly derives from object. The class object is the top of the class hierarchy. Every class is a descendant, direct or indirect, of object. every class inherits the instance methods of object. Now let's look at an inheritance chain. We talked about single inheritance. That means a class has one and exactly one direct superclass. However, that class in turn can have its own superclass. So D can inherit from C, can inherit from B, can inherit from A. Class B is a subclass from class A. Class B is also a superclass from class C. Class D is a descendant from all the classes in the inheritance chain. Class D is a descendant from C as well as from B as well as from A. Once again, let's look at this inheritance structure here. The administrator is a descendant from faculty, which is a descendant from employee, which is a descendant from community member. So my administrator is descendant from faculty and employee and community member, and also from object.